In this video learning activity, the Setup Operator 1B, you will be introduced to video disc technology, enabling you to relate the microscopic scale of the video disc to the care required in its manufacture, and identifying the tools, materials, and components used by setup operators. By magnifying video disc 1,000 times, we may just see the video information. Here we can see the size of a human hair compared to the grooves in a video disc. You see, even a tiny dust particle is enormous when compared to the size of the information on a video disc. In fact, 40 of these grooves would fit on the thickness of a dollar bill. White coats and hairnets are worn in all areas of video disc manufacturing to maintain clean room standards and avoid contamination from dust and hair. Keeping each operation of disc manufacturing clean is essential to the creation of a quality product, one that will be enjoyed by the people you work for, our customers. You have requested an upgrade to Video Disc Setup Operator and will be required to prove proficiency in this task in the next 30 days. The purpose of this program is to aid you in that effort. Our first objective is to relate the very small size of the information that we will place on the video disc and to identify the tools, materials, and components used by setup operators. As a video disc setup operator, you will be working with components made in several areas. At the press, they come together to create the disc. A preform is converted by heat and pressure into a video disc. It is made from compound which was made in the extruder in the compounding area shown here. It is pressed between precision stampers plated of nickel made in matrix, this area. Every element has been made to exacting standards by people doing jobs that no one else in the world can do. Produce the RCA Videodisc. Although it may look like an audio record, that is where the similarity ends. If the disc were as thick as a 4-story building is tall, the grooves would only be a ½ inch wide, a 1/16 inch deep, and the information in them only as thick as 5 sheets of paper. On that same scale, the disc as thick as a 4-story building, it would be a mile in diameter and would cover Indianapolis from East Street to West Street using the Monument Circle for a hub. Extremely accurate replication in plastic is what makes the video disc work. Each operation in manufacturing video discs requires skill and attention to minute detail. Take a close look at the stamper which presses the video disc. Here, under 1,000 powers of magnification, we see the mirror image of the video disc. Look at the other side, before grinding. You will see that nickel nodules are present. In our current process, these nodules measure roughly 1/1000th of an inch in diameter. We must grind stampers to remove these lumps, which are large enough to cover 40 grooves. When nodules have been ground away, they will leave pits and scratches on the back of the stamper. At 5,000 powers of magnification, the broken particles and scratches are visible, and so are other tiny surface imperfections which must be removed during the preparation of the stamper before it may be used to press discs. These imperfections, so small that they can barely be seen by the unaided eye, and so small that they cannot be felt by the finger, must be removed for successful pressing of video discs. The back of a stamper may look smooth and flat, but if only one particle is left, it could create a dent, such as this one. You see, a stamper is only 6/1000ths of an inch thick, roughly as thick as $2 bills. A particle on the back, 1/4 the diameter of a human hair, when subjected to the pressure of the press, would cause a dent. When the press closes, 224,000 pounds of pressure, a weight roughly equal to that of 2 fully loaded tractor-trailer trucks, is exerted. Heat and pressure which occur cause the stamper to slide slightly over the face of the mold. Triflow Teflon has been applied to the mold. or otherwise the stamper would stick to the mold face in a condition called galding. When removed, the stuck stamper may pull a small piece of the mold up. That high point may also cause dents. Any particles left between the mold and stamper can dent the stamper or scratch the mold. For this reason, each step in the process has been carefully specified. You will find copies of this in the section after the glossary of key terms and in many areas on the press floor. Of course, be aware that if you have a run rejected for dents, you have not successfully completed the operation. Here is a dent in a video disc. The area of grinding is an area where the technology of disc production is rapidly improving. In this picture, you can see nickel nodules that have been grown through an experimental process. They are roughly 1/10 the size of the standard nodule. In addition to that development, an automatic grinding process is in use, which leaves stamper backs almost completely free of broken nickel crystals, called the fuzz layer. As technology changes, it is important that we keep step and change methods accordingly. The second objective, identifying tools, materials, and components used by setup operators. We will begin by taking a look at the rubber gloves. These gloves serve two purposes. They are to protect us from the solvents that we will use, and they will protect the steel parts of the mold from the acids and corrosives that may be on our hands. Before entering the clean room or any clean room area, you must have on a clean white lab coat and hairnet. These are essential pieces of the press floor operation. Our first solvent is a clear light solvent called naphtha. It is a relatively slow drying solvent, particularly when compared to freon, which you will also use. Freon is a non-flammable solvent which will not degrade or break down rubber components. The third solvent is acetone. It is an extremely flammable solvent which dries very rapidly. Each of these solvents has its own use in cleaning: the freon, naphtha, and acetone. Make sure to use them as specified and in the correct order. Also make sure to wear your gloves. Here you see a Scotch-Brite pad. Scotch-Brite is a mild abrasive used to buff away high points on mold, remove rust, rough spots, and small burrs. This is DuPont Triflow, a Teflon lubricant used to lubricate the signal area of the mold to prevent galding or sticking of the stamper to the mold face. A brass brush will be used to remove residue of the fuzz layer from manually ground stampers. These are text wipes, a lint-free cloth used to apply solvents, lubricants, and remove residues. Here you may see the mold cart. It is equipped with a hydraulic brake, guide rails for sliding the molds, a pivot for turning the B side over, and a floor brake. Here you can see the A and B mold halves. The A is the lower mold, and the B is the upper mold. You will want to inspect the guide rails of the mold cart and press regularly. You will want to check them for cracks, loose fasteners, or splayed rails. Each mold half weighs approximately 90 pounds. If one were to slide off the rails, you could be injured. This is a hand spanner wrench used to tighten the center plate nuts before using the impact spanner. The air impact wrench with spanner attachment should be used only after the hand tightening. You will want to familiarize yourself with these and the other tools and materials used by the setup operator. When you feel confident in the materials and terms used in this area and the basics of video disc technology, you should be ready to proceed to the next module, 2A, the preparation of the mold. Activity 2A. We will learn the methods for mold preparation. This learning activity begins with the mold assembly having been removed from the press and placed on a mold cart. We'll lock the wheels and then vacuum the mold cart with the central vacuum. We will next want to wipe down the mold cart with a Tex wipe dampened with naphtha. We will want to remove all debris from the cart before moving it to the clean room. Once it is cleaned, we will lower the hydraulic cylinder and lift over the B side. Use the legs to lift the mold half. Recall, it weighs 95 pounds. Before entering the clean room, we will want to make sure that we have on a lint-free lab coat and hairnet, the press floor uniform. Now we'll enter the clean room and wipe down all the tables, shelves, and work areas, making sure that there are no accumulations of text wipes, cardboard boxes, or any other debris. Remember, the object is to keep the room clean. When the room has been policed, we can wheel the mold cart in and slide the B side out. Now we can use the air impact spanner wrench to loosen the center plate nut. You can see the center plate rise. We will want to wiggle the center plate and remove it from the mold. If the center plate is stuck into the mold, it is an indication that there is some compound or corrosion on the center plate, which will require special attention during the cleaning cycle. Once removed, thread the center plate nut onto the center plate and set it on the cart. Do not set it on a mold face, as it would cause damage. Next, loosen the hold-down ring lock, and if the hold-down ring is stuck in place, loosen it using a pin drift and mallet. Take care not to strike the mold while using this method. When it has been turned sufficiently to the counterclockwise, remove it and place it on the mold cart. Now we can remove the stamper from the B-side mold. Be careful, as there are very sharp edges during the coin regions of the stamper. If a stamper is stuck to a mold face, it will indicate that special cleaning will be required later. When the stamper has been removed, replace it into the plexiglass container from which it came. Now we will repeat this process with the A mold half. Begin by using the air impact spanner wrench to loosen and remove the center plate lock nut. Next, remove the A center plate. Again, if force is required to remove this component, you will want to clean it with extra care during the preparation phase. If a stamper has been stuck to a mold face, it indicates a high point. In this scene, you have seen how the stamper and hold-down ring should come off of a mold. After removing them, you may remove the O-rings. Before we do the solvent cleaning, we will want to put on our protective gloves. Remember that they serve a dual purpose, protecting us from the solvents which would cause an irritation of the hands, and protecting the precision steel components from rust which could occur if it were touched by our bare hands. The acids in hands will rust highly finished metal surfaces. To begin the solvent cleaning, take a text wipe, fold it into quarters, and apply naphtha to it. We will want to wipe the bottom of the mold carrier plate and make sure that there are no rough spots or large accumulation of corrosion. Burrs in this area may cause a deformity in the disc. If while wiping it we find a burr has snagged the text wipe, it would be removed with a hard stone. As you could see, there was a lot of corrosion there. Next we'll remove the inner dimension O-ring and the outer dimension O-ring. Take care when handling the O-rings and removing them, as they are not a cheap component. We will want to clean the large O-ring and the small ID O-ring with naphtha and a text wipe. While cleaning it, inspect to see that there are no nicks or burrs. Now we will want to coat the mold with Tri-Flow, and using the Scotch-Brite pad and this circular pattern, we will want to remove any defects on the mold surface.
As stated earlier, a stamper which had been stuck to the mold would either leave a small piece of metal behind or raise a small hill in the mold. This will have to be corrected before the mold can be reused. Certainly any signs of roughness, any corrosion, or any traces of compound must be removed. Pay particular attention to the bead areas of the mold and make sure to remove any corrosion through the center tool bore. When the mold is correctly cleaned and all defects have been removed, we will want to remove the tri-flow and any debris left in the tri-flow with acetone and a fresh text wipe. Again, use this circular pattern. As you can see, there is residue left on the mold. After we have completed the cleaning with the acetone, we will want to clean the mold surface again with Freon. Again, pay particular attention to the stair steps of the center tool bore and the O-ring grooves. Make sure to clean the vacuum hole after the Freon cleaning. Here, the hole was left exposed. Normally, you would cover it with a text wipe to avoid getting naphtha in your eyes. After the vacuum hole has been cleared with naphtha, we can clean the mold surface with naphtha. As you can see, it is a slow-drying solvent. Each cleaning with a solvent cleans the surface a little better. Now we will apply acetone to the mold surface, and using a fresh text wipe, we'll wipe down the mold surface area. During this, the final cleaning of the mold, we will want to carefully clean all areas of the mold, including the O-ring seat. Make sure that these areas are clean and that there are no residues remaining. If on the final application of the acetone the text wipe is not clean, we will want to repeat the cleaning sequence, using first the Freon, then the naphtha, and then the acetone. When you are satisfied that the mold area is clean, apply a coat of Triplon to the signal area of the mold, shown here. You will want to make sure not to get it into either the center area or the coin areas of the mold. If it were accidentally applied to these areas, carefully clean it off using acetone and a text wipe. Once we have completed the cleaning of that mold, we will want to clean the next mold half. Now here we're watching the cleaning of a mold half. The application of the Triflon as a lubricant and to use somewhat like a cutting oil, and the Scotch-Brite pad. Carefully clean the whole area. This is a good time to visually inspect for any material stuck to the mold which would, in mirror image, create a dent in the video disc or a small hill in the stamper. When we feel that we have the area successfully cleaned, coat it with the acetone and clean away the Triflon. At each setup, clean out the vacuum holes of both the A and B mold pack. After pouring some naphtha in through the vacuum inlet, blow it out with compressed air. After cleaning the vacuum holes, clean the mold surfaces using the naphtha. Make sure to clean all O-ring grooves and the center tool bore. Remember that any debris, even the smallest fleck of dust, could cause damage in the next setup. After the mold is successfully cleaned, you will want to clean the hold-down rings, checking them for any bent areas or dents. Observe again the cleaning of the mold surface. Here you can see the Freon applied, the first of the 3 cleaning solvents used after the Triflon and Scotch-Briting of the surface. The Freon beads up much like water on a metal surface. It is a very fast-drying solvent. After each cleaning step, check the text wipe to see if there are any residues present. Clean all areas of the mold. Make sure that there is no corrosion or any traces of compound. Here we can see the mold face being cleaned with the naphtha. And following the naphtha, the use of acetone. Repeat each step until the mold is absolutely clean. Here you can see the fast-drying acetone, which dries leaving no residue. When you are satisfied with the cleanliness of the mold surface area, you will want to coat the signal area with the Triflon lubricant. Spray it onto the text wipe and apply it to only the signal area. Make certain not to get it on either the center area or the coin areas of the mold. With these operations completed, we would replace the O-rings. After cleaning the mold half, make sure to clean the center tooling. While cleaning the center plates, make sure to watch out for any sharp edges. Make certain to clean the inner dimension of the B-pin. Notice the amount of material left on this text wipe. Continue the cleaning until the text wipe will come completely clean. Make sure to clean the stair-step edges of the A center plate. These components must be completely cleaned at each setup. If they are not cleaned, they will be both difficult to install and difficult to remove. When all of the mold components have been correctly cleaned, coat them with the Ryco anti-static spray. This will help to reduce any static charges which have built up on the parts. The static electricity would attract dust particles. Even though you're working in a Class 100 clean room, there is still dust in the atmosphere. It may come from the coat or the text wipe. Before reusing an A center plate, make sure to check it in the go, no-go gauge. At this point, you should be ready to take self-assessment exercise 3A. When you feel confident in the preparation of the molds, you should be ready to take Module 2C. In this video disc learning activity 2B, we will learn the methods for preparation of the stamper and learn the method for stamper and mold assembly. Our first operation will be to select the new stampers. Begin by checking the yellow ticket on the stamper spine. Make sure that the program number of the A and B stampers match. You will also wish to check the stamper number on the yellow ticket against the stamper number found on the center hub of the stamper. You will wish to recall that this number will be written backwards, as is all writing on the stamper itself. Once we have verified that the numbers match, we will need to record the setup number in the logbook. This is a sequential number. When we have loaded the setup number, we will want to record the mold number in the column labeled Mold Number. The number of the mold is found on the inlet and outlet lines for the water and steam. Next, record the number which is found on the spine of the plexiglass container. This is the stamper number. Record the A side in the A column and the B side in the B column. In the column for new master, record whether or not the stamper is from a new master. Next, we will open one of the stamper containers. Remove the stamper and place it on the fixture for the stamper preparation. Put the B side stamper to the right and the A side stamper to the left. Open the remaining container and place it on the fixture for stamper preparation. It will be necessary to use a knife to cut the tape. In some cases, a fingernail may be sufficient. If the stamper you have received from inventory has been background using the manual method, you will use this method for cleaning it. Remember, this is a cleaning operation and is not an operation to remove large pieces of metal, only the residual fragmented metal particles. In the first step, we will use a fine brass brush, and using a circular motion, we will lightly brush the surface. This does not require a great deal of pressure, but more a rapid motion covering all areas. These small pieces of metal must be loosened so that we can remove them during the solvent cleaning. Our first solvent will be Freon. We will apply it to the back of the stamper and clean using a clean text wipe and the same circular pattern. Wipe the back of the stamper. A slight pressure may be employed, similar to the amount of pressure used when polishing shoes. Next, we will apply naphtha to the surface and polish again with another clean text wipe. After the naphtha, we will apply acetone and again repeat the technique. Repeat the operation with the acetone until absolutely no residue is shown on the used text wipe. You will want to repeat this operation until no black residue is left on the text wipe. Cleaning stampers and molds is not a rush job. It will take more time to build another mold if your run is rejected for dents than it takes to clean them right the first time. Once the stamper back is clean, it may be coated with Ryco anti-static spray using the same method used to apply the solvents to the mold, a fresh text wipe, and the circular pattern. Pay particular attention to the coin areas of the stamper, as there is a possibility that particles would cling in these areas. Now, using the airline equipped with the deionizer nozzle, blow off any dust particles which may be on the back of the stamper. You have just seen the method presented, but the actual time required will vary from stamper to stamper, depending on the accumulation of fragmented nickel crystals, which is the black material clinging to the text wipe, and the amount of particulate matter left over from the grinding operation. Only you, the setup operator, know if the last operation left no residue. Here you can see a stamper which has been ground using the Strasbourg auto grinding machine. If you receive a disc ground using this method, your cleaning process will be very simplified. Here you can see the manual grind compared to the Strasbourg method. There is a distinct enough difference between the two that you should never become confused. However, if in doubt, refer all questions to your supervisor. If you receive a disc that has this sort of surface finish, all that is required is the application of the Freon, naphtha, and acetone, and the appropriate text wiping pattern, again until no black oxide is visible. It will not be necessary to use a brush on these type of ground stampers. After the application of the anti-static spray, we are ready to begin the final cleaning. Blow it off with an air hose and turn on the ultraviolet light and turn off the overhead lights. You will want to blow away all dust which may be seen under the high contrast of the ultraviolet light. After blowing off the mold, you will want to turn it upside down and blow it off again. Next, you will want to blow off the mold face. You can see the dust particles under the contrast of the ultraviolet light. Blow them away with the air nozzle. Now that the mold face is clean and the stamper is clean, we may assemble them. Grasp the stamper with your fingers so that your thumb and fingers align with the alignment mark of the stamper. This will help you to orient the alignment mark to the red mark on the mold. Look for the red dot and align the alignment mark of the stamper with the red dot of the mold. Next, we will install the center plate. It should slide easily into the mold, requiring no more than a slight pressure. After installing the center plate, you will want to put the center plate nut on and tighten it using the hand spanner wrench. There is a rejectable phenomenon called time base instability that has been associated with the method used for tightening center plates. After a slight tightening, apply the hold-down ring. This will prevent the stamper from rattling while tightening. It will also prevent the stamper from turning. Tighten the center plate nut with the hand spanner wrench as tight as it will go, and then, using the air impact spanner, tighten it to the specified 80 foot-pounds of torque. You can see it pull the stamper down. Using this method reduces vibrations to the stamper. When the center plate nut has been tightened, you may lock the hold-down ring in place. If it is too stiff, you can use a pin drift and mallet, but be very certain that you do not strike the mold or the stamper. Even the slightest touch of an object as heavy as a mallet or even the pin drift would irreparably damage the stamper.
Before removing the mold to the holding area or out to a press, check the steam water lines very carefully. Make sure the fittings are not damaged in any way. If they have been eroded or have burrs, they should be replaced.
When you have completed the assembly of the molds, take the cart to the staging area outside of the clean room. You may now be ready for the self-assessment exercise 3B. Feel free, however, to review any portion of this module. When you feel confident in the preparation and setup of the mold components as demonstrated in this learning activity, request a post-test from your course administrator.
In this video learning activity, the Setup Operator 2C, you will learn the method for removing molds and cleaning the press. We will begin by depressing the automatic button on the press control and waiting till the press stops its automatic cycle. Press automatic. Next, we will depress the adjust button. This will allow for manual control of the press. Depress the Adjust button. Now we will depress the Water button to initiate the water cooling cycle. Push Water. Critical. Make sure at this point to turn the extruder temperature down and turn the selector from Auto to Heat Cool. Turn the 4 temperature controllers down to 100 degrees C. And turn the selector from Auto to Heating Cooling. Do not leave the selector in this position for more than 25 minutes. To avoid burning compound, change to the cooling mode if you will have to wait for more than 25 minutes for the next setup. Let us review. Push the automatic button and wait till it stops. Press Adjust and then Water Cycles. Turn down the extruder temperatures to 100 degrees C. And change the selector from Auto to Heat Cool, provided that you will have a setup in the press within 25 minutes. First, press Automatic and wait until the press stops its automatic cycle. Then, depress the Adjust button and then press the Water Cycle button. Make sure to turn the extruder temperature down and the selector from Auto to Heat Cool. Now we may open the safety guard on the front of the press, making certain not to kink or bend too sharply the Strataflex supply lines. We will next inspect the B-pin for leaks. Caution! Make certain that the B-pin has cooled before removing it. It may be over 300 degrees Fahrenheit. We will loosen the B-pin hold-down ring. After rotating it counterclockwise, we will be able to remove the B-pin. The B-pin is counterweighted for ease in removing. Make certain it's cool before touching it. Now we will inspect the pin tip for leaks and damage. Looking at the black bud on the end, we can see if the tip has been nicked or scarred. And while the water cooling cycle is initiated, we could see water dripping out around the tip. Our next process will be to fill out the basic paperwork required at the completion of each press run.
When shutting down a press, you will want to enter the following data on your pump ticket: the number of spindles which have been pressed, the shift on which you work. You will want to enter your operator number and the quantity of good discs were. Next, you will want to look on your reject code sheet and determine how many rejected discs you had, including the M0 discs, which is every 40th disc taken to the quality control for evaluation. When all reasons have been documented, you will want to total up the total rejects and add them in the space below the day's date.
In this case, dents on both the A and B side of the video disc. We will fill out the press log sheet and make a label for the discs that were pressed. Next, we'll activate the switch under the turntables so that the discs can move out for easy access. Once the turntable has rotated, we'll place a spacer disc on top of the pressed discs and cover them with the plastic bags made for this purpose. Then we can attach the label which we made and carry the full spindle of discs to the waiting area, a set of shelves near each press. Now we will turn in the appropriate paperwork to our shift supervisor. Now we will prepare to remove the A and B mold. First, we will obtain an empty mold cart. We'll slide it up to the press. We'll also need to get our 24 millimeter open end wrenches and an 8 millimeter Allen wrench. We'll use the open end wrenches to loosen the rear hold downs. These nuts are located on the top of the press. Once they have been loosened, we will be ready to remove the front hold down screw. It is secured in place with the 8 millimeter Allen wrench. Place the hold down on the top of the press. Next, we will turn off the vacuum supply lines and disconnect them gently from the B and the A mold. Notice that while disconnecting it from the B mold, we also disconnected the thermocouple wire. Now we can open the hold down locks as shown here, and slide the B mold out. This will give us access to the steam lines. We at this time can remove the text wipes which have been tied around the steam fittings to avoid any water from getting into the molding area. In the next step, these steam and water lines will be disconnected. Caution: always shut off the steam and water supply valves before removing supply lines. You could be seriously injured if you opened a pressurized steam line. Here we can see the cutoff at the floor for the steam. It is a good idea to wear a leather glove while turning off this valve. A good deal of the heat will be transmitted to the valve handle. When we have securely tightened the steam valve, we will shut off the water inlet valve, shown here. There is no need to shut the drain valve at this time. Now, using our open-end wrenches, we may loosen the steam inlet line to the B mold. Once the torque has been removed from this fitting, it may be removed by turning the nut with normal hand pressure. Take the line and direct it into the trench in front of the press. Use the compressed air to blow the water out of the molds. By removing this one line, the water from both molds may be blown down through the drain. After we have blown out the molds, we can relieve torque on the remaining 3 lines and remove them from the A and B mold. Take care of the Stratiflex lines. They may be damaged if kinked or bent too sharply. Now we may take and move the empty mold cart up to the press. Align the rails and secure the alignment pins. Lock the floor brake. Make sure the brake is locked and the rails are aligned before sliding out the mold. Each mold half weighs 95 pounds, and care should be taken not to have an accident. Slide the B mold out first, reaching through the mold cart as shown here. The A mold may be started onto the mold cart and then pushed on. There is no reason to allow your hands to be between the mold halves. You may now release the floor brake and roll the mold cart away.
We'll lock the wheels and then vacuum the mold cart with the central vacuum. We will next want to wipe down the mold cart with a text wipe dampened with naphtha. We will want to remove all debris from the cart before moving it to the clean room. Once it is cleaned, we will lower the hydraulic cylinder and lift over the B side. Use the legs to lift the mold half. Recall, it weighs 95 pounds.
Now we will go through the pre-setup cleaning and maintenance procedure. We will begin by cleaning the A and B wear plates. We will use IMS Mold Surface Saver Neutralizer. This aerosol will neutralize the hydrochloric acid which is created by the plastic molding process and help to inhibit the corrosion that this acid would cause. Then, using our text wipe, we will wipe away any debris left on the wear plate surface. This is a good time to inspect the wear plates for burrs or rough spots. If any damage has been found to the wear plates, it must be corrected before the setup. We will want to remove rust and burrs before proceeding. To remove burrs on the B plate, use a Blanchard burr buster, which is a hard stone. The B plate is a soft metal and may be stoned. The A wear plate is a hardened metal, and it would take hours to stone away even the tiniest burr. Therefore, clean away rust and rough spots with a Scotch-Brite towel. Next, we will want to blow away debris from the entire pressing area. Begin at the top and rearmost portion of the press. Blow away all foreign matter, paying particular attention to the trimmer router area. Once all the debris has been knocked to the floor, use the air hose and blow it towards the front of the booth. At this time, you should call for a cleaner sweeper. Now, you will want to vacuum the molding and trimmer area to make sure and remove any debris which is left. Open the rear guard and secure it. Remove the vacuum from the router trimmer. Using this vacuum, sweep away any particles found on the trimmer turntables, the unloader arm, around the wear plate surfaces, around the top trimmer platen. Any specks of video disc left from the trimming operation which would fall onto a fresh disc could cause a gouge or scratch defect. If they were to get into the molding area while a new disc were being fabricated, it could damage the stampers. As you can see, it doesn't take very long to keep your press area very clean. If maintained continuously at each shift setup, it should stay in relatively clean operating order. It is because of the sophistication of the video disc that higher than normal standards of cleanliness are required. Make certain that you have your press cleaned thoroughly, that no visible debris may be seen on or around the press. Make sure to reconnect the vacuum to the router trimmer and then close the rear safety guard. Make sure that the sweeper cleaner vacuums the extruder housing, dries up any spilt oil and water, and vacuums the floor with a brush. Have them empty the flash barrel as necessary per shift. It is important that all debris be removed from this area. It is the cleaner sweeper's responsibility to vacuum these external surfaces. Remember, no particles may be tolerated in the molding area. Let's review what we have seen in this learning activity. The methods for press shutdown, method for mold removal, and the cleanup and preparation for mold installation. At this time, you should be ready for learning activity 3C, the self-assessment work exercise. Feel free, however, to review any portion of this module. When you feel confident in the methods for press shutdown, you should be ready to proceed on to learning activity 2D. In this video learning activity, the setup operator 2D, we will install the molds and perform the setup of the press.
Our first step will be to check the B-pin tip and make sure that it's clean. If it has been cleaned, we'll apply moly coat. If it has rust or compound on it, we'll want to clean it first.
When its surface is smooth and shiny, we will want to apply the moly coat to it. This will help to inhibit any new rust and will provide some lubrication for the B-pin tip. To begin with, the moly coat will be applied liberally and rubbed into the pores of the metal. Then it will be wiped off to a thin film. If we were to allow too much of this paste to remain on the B-pin, it may come off on video discs, ruining several of our run. When we have thoroughly cleaned around the B-pin tip, we will be ready for the next step.
The next step will be to check the B center plate and make sure it's clean. If it is clean, we'll want to apply the moly coat. If, however, it is not clean, it should be returned to the setup tent to be cleaned. Note, do not remove the flash from the B plate. Toward the stamper side there is a flash groove, which is to maintain a certain amount of flash in it. Make sure, however, to remove flash from the downward side of the B plate.
We will apply the moly coat to the inside of the B center plate. Using a clean text wipe, we will apply this material. And again, wipe it down.
Next, we will want to inspect the mold inlet and outlet pipe fittings. We'll want to make sure that the flares are undamaged, that they are clean, that the moly coat has been applied.
and that no erosion has occurred. They should have a clean, sharp edge. There should be no rust on them, and if it is, it should be removed with a Scotch-Brite pad. When clean, they should be coated with the Molykote paste. Next, we will want to inspect the supply line fittings. We will want to clean them with Scotch-Brite to remove corrosion and inspect them to see that there is no cracks around these fittings.
Make sure that they are bright and shiny before assembling them to the molds.
Let's review the first 4 steps before we do a mold changeover. First, we'll inspect the B-pin. Make sure that it's clean, free of rust, undamaged, and coated with Molykote. Next, we'll want to inspect the B center plate. We'll want to make sure that it is clean, undamaged, and coated with Molykote. We will want to check then the mold fittings and make sure that they have been cleaned and that they are free of erosion or other damage and have been coated with the Molykote. Fourth, we will want to make sure and clean the supply line fittings with the Scotch-Brite pad, removing any corrosion which may have accumulated on these fittings. Next, we will want to fill out the necessary paperwork on the stamper, program number, and fill out the press run number on the pump ticket. The press run number is the first entry on the pump ticket. The first 2 spaces are for the press number. In this case, the setup was on press number 11. The next 3 digits are for the mold number found on the water lines of the mold. The next 4 digits are for the Julian date. The first 3 are the sequential day of the year, in this case the 232nd day of 1981. The last digit is for the significant year, in this case 81. The last spot is for the setup number, and in this case it is the second setup of the 232nd day of 1981, made with mold number 40 and put into press number 11. That completes the press run number. Next, we will want to fill out the white production control ticket. We will want to enter our run number here, the same as on the POMS ticket. The 11th press, the 40th mold, the Julian date, the 323rd day of 1981, the second setup of the day. You will want to verify at this time the program number found on the stamper and write it on the white ticket and the POMS ticket.
Now we will scribe the run number and setup number on the new stamper, and we will do this backwards as the stamper is a mirror image. As a new setup operator, you may want to practice with a draftsman's lettering template. Use paper and pencil and practice writing numbers backwards until you are proficient in this task. It is essential that this number be clearly legible. You may wish to use the template and your scriber on the stampers until you become good. If someone were to confuse your number, they may think that a good run were a bad run and reject perhaps as many as 1,000 good video discs.
Next, we will want to put the press run number, stamper number, and program number on the press run sheet. Now we will want to tear off the white copy of the white ticket and return it to our foreman. Now we will raise the cart to the correct height
and move it to the press. Carefully align the dowel pins of the mold cart with the press and lock the foot brake. Now slide the A mold into place. After sliding the molds in, the foot brake can be released and the cart may be removed. At this time, check the extruder selector switch and make sure that it is in the heating and cooling position. If the press had been left in the cooling mode, you would want to make sure and change it. At this time, raise the 4 temperature controllers to their set level of 150 degrees C. Now we may begin connecting the steam lines. We will connect them in the reverse order from the way that we disconnected them.
Begin with the B mold outlet line. Then connect the B mold inlet line. Then the A mold inlet line and the B mold outlet line. Hand tighten all 4 fittings at this time. Here you can see a schematic of the inlet and outlet lines of the A and B mold. On the B mold, the outlet is to the left and the inlet is to the right. It is just the opposite in the A mold. Below we see the junction blocks, which you will find on presses 11 through all remaining presses. The left-hand set of junction blocks is for the inlet, and the right-hand set is for the outlet. When connecting the lines, you would want to first take an outlet line to the outlet of the B mold. Then you would want to take an inlet line to the inlet of the B mold. When hooking up the A mold, you would want to start with a left-hand junction block line to the inlet of the A mold and take a right-hand line to the outlet of the A mold. Note in presses 2 through 11 that the junction box are configured differently. In the first presses, 2 through 11, the outer junction lines are the inlets, and the rear more lines are the outlets. Make certain that you are connecting the outlet line to the outlet of the mold and the inlet line to the inlet of the mold. Failure to connect the lines correctly will cause gross warp in the disc. Now we will tighten the inlet and outlet lines. In this case, we are tightening the inlet line of the A mold. Note the use of the torque wrench. The torque wrench has been set to 50 foot-pounds of torque. All 4 lines will be connected using the torque wrench. Torque them each to 50 foot-pounds of torque.
When we have achieved the desired torque on the steam lines, we will want to slowly open the supply valves. First, the water, and then the steam. With these valves open, we will want to inspect the mold supply lines.
To see if we have leakage on the lines, press the steam and then the water button. Inspect the lines to make sure that they are not leaking, and if so, we will be ready for the next step.
Take a Tex wipe, fold it in half, and wrap it around the coupling. This will trap any moisture or any leakage that would occur at this connection. Fasten it in place with a strip of gray furnace tape. This tape should go through the center of the coupling and connect to itself on the other side. Wrap all 4 lines in this way. Next, slide the molds into their position and connect the vacuum lines. Here you can see the A mold vacuum line, and the B mold vacuum line. Now you may connect the thermocouple wire to the B side mold. Next, we'll want to turn on the vacuum and verify that we have at least 22 inches of vacuum. If not, we'll want to search for leaks. We may not start the press run with insufficient vacuum. After securing the molds in place, close the locator locking handles. You may want to rattle the mold slightly to make sure that it has a good seat on the locator handle. Now we may install the B-pin. Recall that the B-pin tip has a very close tolerance to the B center plate. Do not force it. You may want to rock it back and forth slightly, tighten and loosen the hold down ring until it floats into position, as shown here. When you are working with parts of a close tolerance and a high finish, there is no point in forcing them. Once we have tightened down the B-pin, we'll want to tighten down the B-mold hold downs. We don't tighten them down until after the B-pin has been located, as it may be necessary to move the mold slightly to get the B-pin to seat. There is no point in over-torquing these bolts. Simply get them tight enough to hold the mold securely in place, as shown. Now we may mount the B front hold down. Tighten it with the 8mm Allen wrench. Over-torquing these bolts would simply strip them out and be cause for a costly maintenance routine. Now we may remove the protective covering from the stampers. It should be noted that once this covering has been removed, the delicate stampers are vulnerable to damage. Care should be taken to not drag the cover across the stamper. Now we can slide the A mold into place and lock down the locator handle. At this time, we may close the front safety guard. This concludes the Setup Operator Learning Activity 2D, installation of the molds and setup of the press. At this point, you should be ready to take self-assessment exercise 3D. When you feel confident in the methods for installing the molds and setup of the press, you should be ready to proceed on to Module 2E. Critical timing parameters and press monitoring. Now we will go through the procedure for restarting the press following a mold changeover. First, stop the water cycle button. Press Adjust and press the Steam button. This will begin heating the molds and B-pin. The water is off, the adjust is on, the steam is on. Now we will press the center pin switch. The center pin switch activates the B-pin. The hydraulic cylinder, as you see here, is moving the pin up and down. You will want to check by looking in the mold to see the B-pin. Here you see it going up and down. Make sure in its up stroke that it is flush. If it is not, it will have to be removed and shimmed. Now we may switch to the run mode. We will want to check our extruder temperatures to make sure they are at the set points. And now we will purge the extruder. This is to rid the extruder of any degraded or burnt compound. While pressing it, reach in and pull out the ribbon of plastic that is being extruded. Make sure to wear a glove and do not extrude more than 6 feet at a time. After 6 feet have been extruded, wait 40 seconds. You'll want to extrude it until there is no smell of burnt compound. We may then change to the automatic mode and press the extruder button. This will allow the extruder to begin making preforms. This is an injection molding process. Here you see a preform. You will want to look at the amp meter on the extruder housing. It can tell you if for some reason the extruder is pulling too much current, which might be an indication of a mechanical breakdown or burned compound jamming the screw. Here you can see the injection molding of the preform cup. The preform cup rises as it is filled with plastic. When it has completed its cycle, it opens. Be careful when using a puck stick to remove these preforms. Be careful not to gouge the inside of the preform cup. You will want to smell a preform occasionally to make sure that it is not full of burned compound. After removing 10 preforms on 40-second intervals, you will be ready to check the temperature and weight of the 10th preform. Use a pyrometer. Hold the preform with a leather glove on your hand and get the probe towards the center of the preform. You may want to rock the preform around. You should see very close to 375 degrees on your preform. After the temperature has been verified, we can weigh the preform.
The preform weight is optimum at 109.
If temperature and weight were within specifications, we would just simply begin the run. If they are not, you will have to adjust them. Here you can see the adjustment for the preform weight. It is a proximity switch located on the rear side of the preform cup. By adjusting it, we can get either more or less weight. If the weight of the preform is out of specification, we will have to run 2 preforms before rechecking its weight. If temperature was out of specification, we would have to run 10 preforms. Now we will check out the temperatures and line pressures.
Now we will check the mold high and low limits. These are the fin wall temperature controllers directly beneath the alpha control panel. We will want to make sure that the high limit is set at 380 and the low at 295. These temperatures should always be verified against the run sheet, as they may vary from time to time. Below the alpha, here we see the fin wall controllers. The left hand is the high limit, and we have just set it to 380. The right hand is the low limit, and it has been set to 295. Next we will check the compound hopper temperature. It should be at 185 degrees. If it is too low, it is an indication that the extruder has not fully come up to temperature. The extruder hopper is located around the back side of the press, and here you can see the hopper temperature gauge. Check it at each setup to make sure that it is up to the 185 degree limit. Next we will check the water and steam service to the press. These meters and temperature gauges are located at the end of the press line. It is important that each parameter be checked at each setup, because the quality control group will. You would not want to be shut down for something you were not aware of. First, we will check the line water pressure. It is to be 195 pounds per square inch, plus or minus 5 pounds, which would be 200 to 190 pounds of line water pressure. Here we can see the line water pressure gauge. It is on the black pipe to the right of the steam pipe. In this case,